All right, welcome back, everybody. Today's lesson: median and centroid. And so, what we want to know is what is a median and what is centroid. And if you think about median in a list of number, it's the same word, median. It is essentially the value in the middle. But more specifically, this is describing a no, to do one more. There you go. Did I do it wrong? Yeah, there you go. The point, the place, the segment joining the vertex of the triangle to the opposite midpoint, to the midpoint of the opposite side. So this is the, let's say this is our vertex, and this is the opposite side. The line that joining the midpoint of the opposite side to this vertex is called the median. Okay. Let's see if you can see that better. Right, and so this will be our new unit. Well, we have been doing it for 1 week, but this whole unit is going to go into the next level. So, yeah. So, given a triangle, the vertex, and the midpoint, the median, median, right, median, that's this way, is the segment. Let me do it. This. Right, just a piece of a line joining a vertex. That's the reason why it's red. E-R-T-E-X to the midpoint. Man, I hope I'm not shaking. Right, so basically it is the segment, the red one, joining a vertex to the midpoint. That's the T at the end, midpoint of the opposite side. The segment joining a vertex to the midpoint of the opposite side. That is the median. Right. So similar to the angle bisector and perpendicular bisector, it is dealing with a bisector. It is a bisector of the segment. However, it is not a bisector of the. It is not a bisector of the angle. So our angle, no relation. Outside, they equal. Right. So segment joining the vertex of midpoint to the opposite side. Okay. Opposing this. Right, so if we have one, we have a median. If now in a triangle there are exactly 3 vertex and 3 side. So if we have the same a similar triangle, and let's say we have start our vertex, we need 3 vertex to make a triangle. Another one will give us a rectangle, or another one will give us a quadrilateral. A rectangle, which is a special case. Quadrilateral, though, just means we have so side of 4 vertex. In this case, what we have then, if we have the yeah, I really should have done that. Whatever. If we have this, then because a triangle have 3 sides, it would have 3 different, assuming these are midpoint, 3 different midpoint on your sides. So 1 2 1 2 1 2 3 1 2 3. Okay. And so when we connect our median together, okay, so this vertex will connect to the opposite midpoint. This vertex will connect to, well, not these two because they are connecting, the non-connected midpoint. Right, so that's our second, and this vertex will connect to the last. Oh, lucky! So midpoint. If you are connecting midpoints from the vertex, you will meet in one place. Okay, this place that we're meeting, this point that is the common place, is called a centroid. I do have to think about that. So CENTRO, central, no, ID. You need to make it android, like a centroid. So we have the centroid, which is the point where all of them meet. That thing right there. So you need 3 median to find a, well, technically you don't need 2. The third one should be, where the intersect should be the centroid. But at least 10, all 3 should meet at the same place. Now, is it possible that you don't have a centroid in a triangle? I don't know. I'm trying to find out. The best thing to do about this is, it's easy enough that you can determine the midpoint, connect them, see where it is. But for this, we want to see 3 medians of a triangle will intersect at a point called the centroid. So median related to centroid, just as what we learned last time. Perpendicular bisector related to the circumcenter, and what's the other one? The angle bisector perpendicular. Sorry, angle bisector correlate to the incenter. So from the vertex, from the angle, you cannot have, you will not meet after the same length, but the distance from that length will always be equals. Called a centroid. So we have another center to look at. This time it is the centroid. Okay. So if we look at this diagram, let's label the corner. Let's label them. This will be point A, B, C. That's our original triangle. From this original triangle, we divide it up into D, E, F. And notice I am using capitalized letter for the vertex for the point on the graph. So DF will be a point on this graph. 2 point make a line, 3 point make a triangle, unless they're collinear, so not so much a triangle. But then we have a special name for that kind of triangle, a flat triangle or collinear, just like. Anyway, so for this, the medians are gonna be, well, I hope you can determine what that is, but in case you don't know, the first A go to E, right? The second B, the vertex, goes to F, right? And the third C goes to D, the last midpoint. Okay, so these are our median. Let's name the centroid. Do we have a name on there? We actually don't, so you can name it whatever you want. Right, similar to our previous centers of a circle, the centroid will now be named P. Right, so what are the special properties? So, because these are bisector, sorry, these are midpoints, what are some special property that we can glean? In this case, the centroid divide the median into thirds. So if you need to find a third of a line, with the compass we can divide in 2, but we cannot divide into 3. Centroid, however, will let us divide it into 3 by making the line into a median of some triangle. So with that, the special property. I'm going to go ahead and put P where P should be. Okay. The special property, right? The segment A, vertex A to P is going to be twice of P to E. Right? So the segment A to P, notice it is a lot longer than P to E. It is 2 times P to E. The point P is 1/3 of divided into 2/3 and 1/3 of the whole segment. Okay, so because of that, we can say the opposite, that is PE, is going to be 1/2 of AP. And you guys remember in the beginning of the year, we talked a little bit about dividing a segment into portion. This is the follow-up. Right. So because AP being twice of E, that basically give us 3 different segments. AP then is going to be about 2/3 of AE. Okay, and PE, the little small segment, is going to be the remaining 1/3 of AE. So this allows us to divide a segment into thirds, and it is important because so far we can only divide a segment into halves. All right, so that's our first piece of note. The second thing that we're going to be looking at will be these. Let me go ahead and make a line. Okay, so this is our first portion. Make use your notes, include this, and see if you can try to do it on, try to apply these concepts, these ideas onto the, see if you can try these ideas on the notes. Okay, so let's move on to the next piece of information, which is the altitude. Okay, so we know the median cut is the line from the vertex to the, vertex to the midpoint. The altitude will also be a line from a vertex of a triangle. Okay. Now you all know, you guys may have heard of this altitude before. It is also known as the height of a triangle. And if you don't remember what the height of a triangle is, then we will have a chance to relearn or to learn something new today. If you do remember, then hopefully we'll learn something new all the same. All right, so the altitude of this triangle would just be the length, the distance from a vertex, doesn't matter which one, to the vertex. I need a pencil for this portion. Perpendicular distance from the vertex to its opposite side, and it does have to be perpendicular. So I am going to extend this line because I don't have enough to use it with this compass. Okay, so to find the perpendicular distance, I'm going to go ahead and extend the segment. I'm going to go ahead and find a point, a radius, and basically make an arc of equal radius, equal distance. And from there, I'm going to go ahead and find the intersection of some congruent. Let's go ahead and do a little bit longer. So this portion and this intersection, this portion. Okay, let's make sure that's correct. So the intersection here. Oh no, that's not right. There you go. So this is our arc. This is our radius from the vertex and we are using, let me erase this thing on. Gotta do it correctly, you know. We don't have a machine to do this for us. We do it by hand for a reason. And the same, connecting this end. Oh, is this correct segment? All right, so this point, this intersection, and our vertex would be perpendicular. This line to go through this point would be perpendicular to the last side. And I am going to start erasing because the length, the distance from these and from these this segment are congruent, and the distance, the length, the radius being the same over here also mean that these segments are congruent, right? What we have is a kite, and the intersection of two lines on the intersection of the diagonal of a kite, basically these two being diagonal, will always be perpendicular. So allow us to say, oh, okay, we got ourselves a perpendicular segment. Okay, the kite will probably not have 90-degree angle, but still will be able to have perpendicular segment. Like, yeah, you can skip around on these. All right, so this segment right here, it is 90 degrees to the opposite side, and it's called the altitude. Let me use regular setting. Altitude. Okay, this is the main idea. So that's one segment give us an altitude, and similar to the median, one segment give us the altitude, three segments give us something else. All right, so a segment joining a vertex to vertex is special, so let's change the color of this one. Vertex, do it twice, do it right. To the opposite side, so that it is perpendicular. All right, let's color code this thing. So perpendicular, little blue squares to that side. Okay, so we're using we create a what do you call that thing? Kite to and connecting the diagonal to make it perpendicular. All right, where we at? I don't know. Oh yeah, that's it. So that's the definition of altitude. Okay, so what about the altitude? The altitude can be inside a triangle or outside of a triangle or a side of a triangle. So let's see some example of this. If we have this triangle, this is the thing about altitude. It does not have to be inside of a triangle. Okay, so an altitude can be inside of a triangle. Is that right? Yeah, that's right. So that means we just have a very regular, totally not obtuse, totally acute, essentially. angle. It's acute. So that way, the altitude is always going to be, I'm going to be lazy here. Altitude is always going to be inside. That should be 1 point of the triangle. Now we can also have it outside of the triangle, and this happens whenever we have a obtuse triangle. So let's make it wide. Now because it is obtuse, only only two side will be outside. So let's make this 1. We're going to extend this guy and go straight down. So this will be our altitude. And for this last one, we're going to have to extend the third side. Boop, 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 and then perpendicularize it. This is an eyeball, so bear with it. Alright, so notice we do have 2 exterior altitude. Okay. Of course, they do intersect if we extend them. If we extend them further and further and further. So the intersection is unlike the other one. Unlike everything else, it's going to be way off, way off the other thing. And finally, we have a altitude that is inside. Well, that is the side of the triangle. So if you have a triangle that does also contain a 90 degree, that means 2 of the sides. Right? Notice this common 2 this time will be the altitude. So in this case, because this is 90-degree triangles, this will be an altitude. This will be a second altitude, and you have a third one on the inside. Notice the intersection, though they will still intersect. The intersection is at a vertex for this particular for these particular type of altitude. And where they intersect, where these altitude intersect, these are called the orthocenter of the triangle. So let's make a fake one. I'll try to do something similar to what you have on your notes. And connect the dots. For the first, connect the dot. Yeah, you have to eyeball. I'm eyeballing this one, so because I'm not going to waste a lot of time. Just assume that these are going to be perpendicular to the opposite side. There will be some relation, and this point will be our orthocenter. Okay. So let's label the name. This guy, let's call this A, B, C for our triangle, with the altitude ending at D, E, F. Okay, orthocenter. Orthocenter, I think, deal with the center of rotation, especially if you have a uniform mass item. So if you throw a ball and it rotates in the air, the point in the center, that is your orthocenter. Anyway, let's finish this up. Yeah, so that's why your boomerang rotate in a circle with a hole inside, because its orthocenter is outside of it. Anyway, let's see. I think that's the case. Anyway, so auto center definition, the tree altitude. Right, so this is our key facts here. Auto center deal with altitude, and you do not need to know this. Okay, and we will do an assignment of this of a triangle intersect at a point called the auto center. Okay, so the altitude that we have, for example, are going to be from A to E, perpendicular segment, B to F, right, from this vertical to the opposite, and the segment C to D. Okay. For this one, we named it point P is the auto center. Now, doesn't mean we always name it P, but this is what we're going to name it here. Okay, so that's that's what we're covering today and tomorrow. Just prepare first. I will make another video relating, going over the well, what we can use, but you should be able to apply the fact that for median, the segment of the median intersected by, well, separated by the centroid is about 2/3 of the whole length, or that is twice of the the longer segment after the cut the intersection. No, after the point up after the centroid is always going to be twice the length of the shoulder segment. So that's a fact that we can use for the practice and homework. For altitude and auto center, there is nothing. But altitude and auto center can have the intersection. It is the auto center don't have to be inside of the triangle as we had seen earlier. It can be outside of the triangle. So that's the two things. Okay. All right. I will go ahead and start on the notes differently, and you guys have to wait on that one.